Hello, in this video we will be explaining the algebraic method of balancing chemical equations. So when you say algebraic, it means from the word algebra. So this method is kind of more mathematical than the inspection method, but we will explain what this means. Okay, so say for example you have an equation. Again, let's use the simple equation, which is something like H2 plus O2 is equal to H2O. And again, we have balanced this before. This would be balanced like this, right? That's balanced. And then why is this balanced? Because again, if you count the number of hydrogen, that is 4, 2 times 2. And if you count the number of hydrogen on the other side, that's 2 times 2, that's also 4. If you count the oxygen, that's 2 times 1, that's 2. And then if you count the number of oxygen on the product side, that's 1 times 2, that's 2. So they are equal. So notice what is happening here. This is because of the conservation of mass, meaning the number of hydrogen before in the reactant side must be equal to the number of hydrogen in the product side. And the number of reactants on the number of oxygen in the reactant side is equal to the number of oxygen in the product side. So they are always equal. Now, here's the thing. What if I don't know what the coefficients are? What if I don't know what the coefficients are? So in algebra, you notice if we don't know something, we replace it with a variable like x, 2x equals y plus b, something like that. 2x equals mx plus b or something like that. So we replace unknown numbers by variables, right? So what we can do is we can, for example, if we don't know the coefficients, I can say, well, H2 plus O2 is equal to H2O. And then there has to be a coefficient here, which I don't know. So because I don't know, I use a variable A. And here I don't know the variable, so I'll use B. And I don't know the variable here. I don't know the coefficient here, so I'll use C. Okay? I notice that because of the law of conservation of mass, the number of hydrogen atoms in the reactant side is always equal to the number of hydrogen atoms in the product side. So how did we get the number of hydrogen atoms here? We have coefficient, subscript times coefficient. 2 times 2 is 4. But let's say you don't know. Of course, you know that this is 2, but let's say you don't know the value. So you just replace it with A. So how do you know the number of hydrogen atoms? Well, it's still the same. Still subscript times coefficient. So 2 times A. So now the number is 2 times A. Okay? And then, how about on the other side? Well, that's 2 times C. Again, subscript times coefficient. And then how about the number of oxygen? So that's 2 times the coefficient here. In this case, you know it to be 1, so 2 times 1 is 1. But if, in case you don't know, so you have 2 times B, so that's 2B. Then how about the oxygen on the other side? That's 1 subscript times coefficient, 1 times C, 1C. Okay? So let's erase this like that. And then my point is, because the number of elements on the reactant side must be always equal to the number of elements on the other side, guess what? This 2A is the number of hydrogen. This 2C is the number of hydrogen. So they are equal. They are equal because the number of hydrogen on the reactant side is always equal to the number of hydrogen on the product side. So 2A must be equal to 2C. In the same manner, oxygen's number in the reactant side is always equal to the oxygen number on the product side. So the oxygen number on the reactant side is 2B. On the reactant side, it's 1C. Okay? So what have we done here? What we did was we replaced the coefficients with unknown variables. And then we constructed the count of hydrogens, the count of the elements on both sides. And then we said that because of conservation of mass, the number of elements on this side is equal to that side. So we can construct an equation. We can construct equations. We can construct equations for the H. We can construct equations for the O. So let's call this equation 1 and let's call this equation 2. Okay, so now this is now why it becomes an algebraic method, because you have an algebraic expression with variables, right? And if you remember your math, you can solve for these variables if you have different equations. But the only problem is, how many unknowns do we have? We have one unknown, two unknown, three unknowns. We don't know A, we don't know B, we don't know C. How many equations do we have? You have two equations, equation 1 and equation 2, right? The problem is, in math, it's always like this. If you have three unknowns, you must have three equations to solve it. If you have two unknowns, you must have two equations to solve it. In this case, you have three unknowns, but you have only two equations. Okay? So the thing is, when that is the case, there's another trick in algebra, which is to assume a value. Okay? We don't know A, we don't know B, we don't know C, yes, but I can assume a value for one of them. So let us assume that A is equal to 1. Okay? And you can think of it as, when you assume that A is equal to 1, you kind of made a third equation. Because you see, this is first equation, 2A equals 2C. Second equation, 2B equals 1C. Now you created a third equation, which is A equals 1. That's still an equation, right? So therefore, you have three unknowns, and now you have three equations. So you can now solve for it, right? So now we use techniques in algebra, which is, one is substitution. You can substitute in the value. Say, for example, this one, 2A equals 2C. So from equation 1, 2A is equals to 2C. This is equation 1. Again, because we assume that A is 1, we can replace that and say, well, A is 1, because we assume that A is 1. And from that, we can have 2 equals 2C, right? And from here, we can have C equals 2 over 2, or C is equal to 1. Okay? So, again, what did we do? We created algebraic expressions. We assume one value is equal to 1, namely the A. We use substitution method to substitute that into one of the equations. Then we can solve for C. So now, once we assume that A is B, A is 1. So if we assume that A is 1, we now solve that C is 1. Okay? And then, from there, we can also use equation 2. Because now we know what is A, now we know what is C. So if we look at equation 2, we know what is C. So we can solve for B. So now we can do the second equation, which is, let me remind you, 2B equals 1C. So 2B equals 1C. And again, we have solved from the previous step that C equals 1. So I can just say B equals 1 times something. But that something is here, the C, which is equal to 1. So what happens is, this becomes 2B equals 1 and B equals 1/2. Okay? So now we have solved that B is equal to 1/2. Okay? So we did not know what A, what B, and what C is. But using the equations that we have constructed from the elements, and using our assumption that A is 1, we now have solved that A is 1, B is 1/2, and C is 1. Okay? And then, the next step is then to replace that, because before we did not know what A, what B, and what C is. But now we know them, so we say, well, A is 1, so this is 1H2 plus B is 1/2, 1/2 O2. That gives you C. C is also 1 times H2O. Okay, so this is now a balanced equation. But then again, and the rules in writing a chemical equation dictates that we should use whole numbers. Because again, if you think about it, it doesn't make sense to have 1/2 of an oxygen molecule. So again, to do this, you have to multiply the whole thing with a number. And that number is 2, so that this becomes a whole number. Okay, so let me remind you that that is valid, because, for example, if you have the equation 8 equals 6 plus 2, you can multiply both sides by, let's say, 4. And that becomes 4 times 8 is 36, plus 4 times, oh sorry, equals 4 times 2 is 24, plus 4 times 2 is 8. I'm sorry. 4 times 8 is 32, right? 4 times 8 is 32. So 4 times 8 is 32, 4 times 6 is 24, 4 times 2 is 8. So you see, it's valid because you know that 24 plus 8 is really 32. So what I'm trying to say is, if you multiply any number to the left side, as long as you multiply it also to the right side, the equation remains valid. So the same thing for the chemical equation. If I multiply this by 2, as long as I multiply it to every term, meaning in the right side, in the left side, and also in the right side, it also is the same. So 2 times 1 is 2, plus 2 times 1/2 is 1, plus 2 times 2 is 2, H2O. And if you notice, this is actually the same value of the balance equation that we have presented before. It's just that this time we used algebraic expressions to solve for it. Now, in this case, we use an algebraic method, and we only have to use substitution technique, which is to use a value of one variable to solve for, substitute into an equation, and we can solve the values of the other variables. But in other more difficult algebraic expressions, you might use an elimination method. And this elimination method is quite more advanced, and it's just to happen that our example here is very simple, and I chose that to be simple because if it's very difficult, you would be lost in trying to understand what the algebraic method is. But in the next video, I will have an example where the chemical equation is very, very complicated, but it still uses the same techniques, except that it now uses the next number will now use an elimination method in addition to substitution to solve for the equations. But again, how do we do algebraic method? Very simple. We construct algebraic expressions to the number of elements on the reactant side and on the product side. Again, that's done by multiplying the subscript with the coefficient. So this is 2a, and then the oxygen on the other side is 2c. And then we equate the two algebraic expressions from the left side and the right side, because at the end of the day, it follows the conservation of mass, which is the number of elements here is equal to the number of elements on the other side. So we equate that. Now, once we have an equation, we assume one value. So like a is equal to 1. And then from there, we can use substitution method for simple equations to solve for the other values, or we can use elimination method to solve for other complicated equations. And again, that example that uses elimination will be in the next video. But essentially, I wanted you to understand the concept, and the concept is, because a chemical equation is still an equation, right side, left side, right side is still equal to the right side, right side is still equal to the left side, then you can make algebraic expressions, and those algebraic expressions can be equated together, and then those equations can be treated like algebraic equations, which means you can use substitution and elimination to solve for the coefficients. And once you solve for the coefficients, you just have to make sure that they are in whole numbers, and voila, you have balanced the equation using an algebraic method.